All right, welcome to our first video on polynomials in this flipped video unit. The first thing I want to talk about is what is a polynomial. Just get a definition for it. Polynomial is any expression that has terms with x's raised to whole number powers. And it's the whole number powers part that's important. Remember that whole numbers start at 0 and work your way up. So whole numbers, we're talking 0, 1, 2, and so on. Any term that has a whole number power can be part of a polynomial, but each of those terms has to satisfy that requirement. So I have here for you in green are a few examples of things that are polynomials. You'll notice that here x to the third power, we call it x cubed. Your exponent is a 3, that's a whole number. Plus 5x squared, whole number, it's a 2 for your exponent. Minus 7x, remember it's just x raised to the first power. So the exponent there is a 1, and then the plus 4. Notice there isn't a variable in that plus 4. That constant term is okay to have in a polynomial. Really, when you have a constant term, it's like having x raised to the 0 power, because any number to the 0 power is 1. So you really just have 4 times 1 to give you that 4. So constants are going to be okay in a polynomial. Polynomial, in this case, 2x squared minus 7x to the 6th plus 3, that's fine. Your polynomial, poly means many, but you don't have to have a lot of terms. You don't have to have many terms to be a polynomial. In fact, 5x is considered a polynomial, even though there's only one term. Sometimes you hear it called a monomial because of one term, binomial for 2 terms, trinomial, and so on. Polynomial just includes any of those, regardless of the number of terms, as long as all of your exponents are whole numbers. So if all those things are polynomials, what are some things that aren't polynomials? Here are a few examples. This one starts out okay. You'll notice it's the exact same expression as the first green one here, x cubed plus 5x squared minus 7x plus 4. But then this plus square root of x is tacked onto the end. A square root expression, if there's a variable in there, is not going to be part of a polynomial expression. It's something later on we'll call a radical expression or root expression. Actually, something I want to mention here, you may or may not have seen this before. I'll probably ask you about this in class tomorrow just to make sure you've seen the video. When you're at the square root of x, this is like having x raised to the 1/2 power. Raising something to the 1/2 power is like taking the square root of it. So we'll be dealing with those fractional exponents later on if we haven't seen them yet in class. This one term makes this not a polynomial, even though 4 of the terms could be part of a polynomial. One term can eliminate the whole thing from being a polynomial. Here 2x squared plus 1 over x. You can't have variables in denominators of expressions. That would actually be a negative exponent. 1 over x, that would be like having x to the negative 1 power. If you've never seen negative exponents before, we'll be talking about those in this class a lot. Something similar here, 8x to the 10th power, well that's okay. But then 6 over x squared, that x squared being in the denominator makes this not a polynomial because having that expression in the denominator would actually give it a negative exponent. So this 6 over x squared would be like having 6x to the negative 2 power. Therefore not a polynomial because negative 1, negative 2 aren't whole numbers. 1/2's not a whole number. And then finally an expression with your variable up in your exponent, like 4 to the x power, that's not a polynomial. That's something called an exponential function that we'll be looking at later on in this class as well. So your variable cannot be in the exponent. It cannot have a power that's not a whole number. Whether that's a fraction or a negative integer makes that not a polynomial. So it's a quick look at what is a polynomial, what isn't a polynomial, and some examples. If we're going to work with polynomials, it's important that we're looking at polynomials that are as simplified as possible. And so the next thing I want to talk about is how we can take a polynomial and put it in standard form. When we say a polynomial is standard form, we've done 2 things to that polynomial. The first thing is we've combined all our like terms. We've simplified it down as much as we can, like you'd expect to do with any algebraic expression. The second thing we're going to do is we're going to put the terms in a certain order. We're going to put the largest exponent out front, and then we're going to work our way down. So our exponents will decrease as we go through the expression. Right? I have an example problem that I'm going to work through with you here. I have a polynomial. You'll notice every term here has a whole number exponent. 2, 1, 3, 3, 2, 1 again, and then constant means x to the 0 power would be your exponent. I'm going to write this in standard form. You'll notice, first of all, there are some terms that we can combine. And as we combine those terms, it's good to combine those in the proper order. You kind of do this in one step. If you'll look at the expression, you'll notice that the third power, x cubed, is our largest exponent. That's going to be important to us in a minute here. So we're going to go ahead and combine those like terms first. Negative 2x cubed plus 10x cubed going to give us 8x cubed, or 8x to the third power. So that takes care of those two terms, and you may want to say, okay, well, I take care of those and work my way down now. My next exponent is going to be x squared, an exponent of 2. And 5x squared minus 9x squared is going to combine to be a negative 4x squared. Okay, took care of those. Positive 6x and a positive 7x will combine to give you a plus 13x. And then that constant, that minus 3, had nothing to combine with. That's okay. We're just going to leave that here at the end. That's going to be, the constant's always going to be the last term in your polynomial because it's the smallest exponent you can have in a polynomial, a 0 power for your exponent. So this is a polynomial that is now written in standard form. All my like terms are combined. I have the largest exponent out front, and I'm working my way down. All right, so let me give you a chance to practice that on your own. You'll notice there on your guided notes, I believe you'll have this problem written there next. I have to take this polynomial expression and write it in standard form. If you go ahead and pause the video for a second and work that problem, then we'll come back and look and see how you did at it. Okay, you're back now. And let's see, we've got x to the fourth is our largest polynomial, or is our largest variable in our polynomial. So we're going to start with that. There's nothing to combine there. So we're just going to leave that as 2x to the fourth power. X to the third power, again, nothing to combine. So most of this, putting this one in standard form, was just arranging the terms correctly. Make sure you bring that negative sign with it. It's a minus 3x to the third. 6x squared comes next, nothing to combine there. Now we do have what we call linear terms. We just have x raised to the first power. To combine, an 8x and a 10x will combine to give you 18x. And then finally your constant of plus 5 on the end. So now we have a polynomial there that's written in standard form. The reason we write polynomials in standard form, one, is to simplify them, and two, is that when we start looking at how to solve and how to graph these polynomials, if we all have these in the standard form, it's much, much easier to deal with, as opposed to a long string of jumbled up terms. And a couple of things I want to mention about a polynomial, two really important characteristics of a polynomial that we'll see used tomorrow when we start to look at graphs. One of those is the degree of a polynomial. The degree of a polynomial is the largest exponent that you have in that polynomial. So degree is just the largest exponent. So in this case, our degree would be 4. This number here is my degree. It's my largest exponent. So you can just say the degree is 4. You can say it's a 4th degree polynomial. You hear that said both ways. And then the other thing that's important here is to identify the leading coefficient. And that's exactly what it sounds like. It's the coefficient that's out front. It's at the lead of the polynomial once it's written in standard form. So in this case, this 2 is your leading coefficient. So by writing things in standard form, we can quickly identify the degree and the leading coefficient. They're both going to be in that first term because you put this in order of decreasing exponents. Your largest exponent is going to be there out front. So the important things that hopefully you've gotten from this video are be able to identify what a polynomial is and is not, be able to take a polynomial and write it in standard form, and then be able to identify the degree and the leading coefficient of that polynomial. Those are the things that we're going to be practicing in class tomorrow. So I will see you then.